So functions can be combined just like numbers. I guess technically when you get down to it, that's what a function value is. It's a number. So you can combine functions pretty much the same way you can numbers. And so it's really just kind of a notation thing. Make sure we understand this first part anyway. The fifth one, there's 4 of these, and then I'll do a 5th one. It's a little different. You may have seen it before, but so combination. So it's just adding functions, subtracting functions, that multiplying, dividing started with. Yeah, so f plus g of x. So we're basically naming a new function out of 2, and this particular one is f plus g, and it's just like you would hope. What you do is you take the 2 functions and add them together. Okay? Same thing on subtract. Same thing on multiply. Yeah, so you're just going to subtract. You've got these 2 functions, f and g. We're going to make a new function out of it, f plus g or f minus g, and it's just like you would hope. Subtract, add. On the times, one thing I'd point out, so there's not a symbol there between them, but that's times. It's understood to be times, multiply. And then f divide g of x, you take f of x and divide it by g of x. And the one thing I'd say about that one is, so the rest of these, the top 3 here, pretty obviously, if you're combining them, you're combining their domains, and so it's going to be where they overlap domain-wise. But when you get to the divide, note there, you've introduced, if you will, even if you neither f or g have a denominator, you have a denominator now. G of x is the denominator, and so as we know, denominators can't be 0, and so your domain is also going to have to include that. That part I may specify a little more about that in a second. All right, so let's just do a couple, and like I said, they're fairly straightforward. F of x equals x squared minus 3x plus 2, and g of x equals x minus 2, I believe. Yep, x minus 2. All right, so what is the f plus g of x function? We just take f of x and add to that g of x, so that's just that one plus that one. And of course, combined like terms is really all you can do with that. So right, f plus g is going to be x squared minus 2x. The 2's cancel. Now the minus, the one thing you have to be careful there with, so it's f of x minus g of x, and so when you write it out that way, it's one thing, but what would be wrong with this? Anybody see a problem with that? Well, you're subtracting the whole g of x, and so the problem there is, yeah, you've got to somehow note that whole thing is subtracted, because what does that mean? You got to distribute the minus. So on the g of x, when you do the minus g of x, yeah, you got to distribute the minus sign, and so that's going to change it to a plus, and that's a whole another thing there. Because the 2's aren't going to cancel there. What are we going to get? X squared minus 4x plus 4. Combining the like terms. Everybody with me there? So on the times, I didn't check, but when you multiply, you know, if you're doing polynomials, multiply those, so they probably will want you to, unless it's too long, but they probably will want you to multiply that out. Go ahead. In this case, it's extended FOIL, but you know what I'm saying? So multiply those all out, which is a bit of a, with the ones I chose here, it's a little bit longer than normal, but what, x cubed minus 2x squared minus 3x squared plus 6x for those two right there, and then the 2, you got 2x minus 4 when you distribute those. Is that right? Did I do that right? Does that look right? Anybody okay with that?
Yes.
Okay, thank you. All right, so that's x squared minus 5, sorry, x cubed minus 5x squared plus 8x minus 4, combining the like terms. Look okay? All right, so on the divide, finish this off. Just a couple of points about that. So if I do f divide g of x, x over gx, or whatever you want to call it, yeah, you divide the two, f of x divided by g of x, so that's going to be x squared minus 3x plus 2 divided by x minus 2. And that's what I was saying, okay, so on these others, when we combine these, so the domain on f and g, all real numbers, well, when you get to the combination, it's still all real numbers. And you know, if you're restricted on one of them, you'll be restricted on the combination too, but here though, my point is, there is a restriction now in the domain that we didn't have for the regular ones, because what can't x be here? X can't be 2, all right? So we have, that would make the denominator 0. Right? So we have that domain restriction now that we didn't have. Now the other thing on this, does anybody else see something we could do to that?
Synthetic division.
You could do synthetic or even simplified just by factoring. We could do division, yes. But just look at this, if I factor the top, isn't that x minus 2, x minus 1? That's the factoring. And my point I was getting to was, yeah, that reduces down to just x minus 1. They won't always do that, but since it's still f divided by g, g still would be 0 at 2. That still comes with that restriction, okay? So even if you do, if you leave it like that, that's okay. But it may want you to reduce it, but you still have the fact that's still going to be not equal to 2. And remember, we talked about that. If we were graphing this, you'd have that hole there at 2. Anyway, one other type here. Any questions about that? Is that okay? One other type on this is, okay, so let's change our functions up here. Let's do f of x equals x square root of x squared minus 9, and then g is 5x minus 7. So the other type of problem that we may encounter here is this. What is f minus g negative 4? And I guess there's a couple ways we could do it. If we already had done f minus g of x, we could just use that, but I don't have that. Wouldn't be that hard, but what does this mean? That's our input value, right? And so when I go to subtract these, I'm going to subtract f of -4 minus g of -4, right? Isn't that what that means? So I'm going to input both -4 for both, and then I can subtract. So f of -4 is, just plug in -4 there. You got 16, square root of 16 minus 9, that's going to be square root of 7. And unless they say round it, I'd probably just leave it square root of 7. So that's square root of 7, g of -4. Well, that's a little easier. Just plug in -4 to the g, so that's -20 minus 7, so that's -27. And like I said, unless they say round, let's just write that as, I don't know that any of them will actually come out that way, but if they did, that's probably how we should write it without rounding. Is that okay? Couple more in this regard, okay. All right, what about, so what would fg of 5 be then? I think this one comes out a little nicer. Fg of 5, well that means time, so we do f of 5 times g of 5. And so f of 5, I think it comes out a little nicer. F of 5, so we plug in 5 there. 25 minus 9, square rooted, which is the square root of 16, 4. So this f of 5 is 4. And then g of 5, again, it's 25 minus 7, so that's 18. So f of 5 is 4, g of 5 is 18. So that wants me to multiply there. So just multiply those two. 72? Does that sound right? Okay. All right, one more there. Because we can also do this. What about this? F over g, f divided by g of t plus 3. What would we do there? Well, again, that's our input value, so instead of x, I've got an input value of t plus 3, so that's what I do. I do f of t plus 3, and it's divide, so divide that by g of t plus 3. See what that gets me. All right, so we start with f of t plus 3, so that is, plug in the t plus 3 here. So it'd be t plus 3 squared minus 9. And that does simplify. How do I simplify that? We haven't done this in a while, I don't think, but t plus 3 squared, we got to pull it out, don't you? T plus 3 times t plus 3. So you got t squared plus 3t plus another 3t plus 9. So that's t squared. This t plus 3 squared is t squared plus 6t plus 9. And then we got the other part, minus 9. And so that one, all it really simplifies down to is, well, the 9's go out, so it's t squared plus 6t. So that's going to be the top there. And then the bottom, g of t plus 3, well, do the same thing. That's going to be, plug in t plus 3 for x there, so it's 5 times t plus 3 minus 7. Which that you distribute, and then simplify. I believe that's going to get us down to 5t plus 8. And so that's what goes for g of t plus 3. I don't think there's any simplifying to be done there. All right. Any questions about that? So far, so good? Not too bad on that. Now, another way we can combine functions that's not, we haven't had one, we don't do this with just regular numbers, is the composition. Y'all seen that before? Composition function? Well, it too takes two functions and combines it, but it's called a composition. And it's, like I said, it's different than plus, minus, divide, totally different. But here's what it is. Basically just kind of define it. F, and here's the symbol. Maybe that'll, yeah, you may have seen this before, just don't remember what it's called, but yeah, it's F circle G. F circle G. So that's a new function we can make out of two. So notice it's not times, it's circle. It's the composition symbol there. And here's what that means. The way you do F circle G, that composition is you take F of G of X. So it kind of is a process there. So let me do one of those. All right, so f of x equals 3x plus 4. G of x equals 2x minus 9. So what they'll say is find f circle G for those functions. And so what do we do? Well, f circle G of x is f of G of x, or f parentheses G of x. That's what they want us to do. In other words, what I'm saying is it may not show you the whole story there, but that's what you do. F of G of x. Now what does that mean? Well, as we know in math, what do we do first? Parentheses first. Well, there's not really anything to do in the innermost parentheses, because that's just x. There's nothing to simplify there. But in the parentheses here, you got g of x. So you do g of x first. And in this case, g of x is 2x minus 9. So, and there's nothing more to do to that. Just kind of replace, in this case, we just replace g of x by 2x minus 9. Everybody with me? Just replace. Now then a little more work comes in, because now we want to do f of that, which is, what that means is take the 2x minus 9 and plug that into the f function for x. So we got 3 times 2x minus 9 plus 4. That's 6x minus 27, right? Distribute. Plus the 4, so it's 6x minus 23, right? Okay. Now, next point here. What if I reverse that? On the adding, multiplying, I can reverse them, won't make a bit of difference. But if I reverse f and g, do g minus f, that changes it. Well, same thing here. If I do g circle f, that changes it. Because what you want to do, the way I look at it is, you kind of leave it in the same order that it's showing. Here, f circle g, so it's f and then g here. F on the left, g on the right. Here we got g on the left, f on the right, so you leave that the same. You with me? See that? So you leave them in the same order. Now that changes it because for this one, if I do g circle f of x for these functions, that's going to change it. I'll just redo the problem here. All right, so let's find g circle f. We found f circle g for those. Let's find g circle f for those. Well, g circle f of x, you leave them in the same order, so it's g of f of x. What's different about that? You do the f of x first. In other words, you're going to replace f of x first in the parentheses there. Do the parentheses first. So you're going to do f of x is 3x plus 4. Replace it. Then you do g of that. And so you take 3x plus 4 and replace it in the g. So that's 2 times the x. So the x is 3x plus 4. Cool. All right? 2 times 3x plus 4 minus 9. That's going to give us a little something different. 6x plus 8 minus 9. 6x is the same, but the constant is minus 1, isn't it? 6x minus 1? Yes? Is that what you get? So they're different. Slightly different. Sometimes they're a little more different than others. Okay. Now, let me show you this then. So let's change our functions here. Let's do f of x equals square root of x minus 1. G of x equals x squared minus 4. Okay. All right. So, number 1, let's do g circle f. So the deal is, yeah, it makes a difference which one's which. And on the composition ones, they do, actually I think on most of the problems, they want you to do both of them, f circle g, g circle f. This one wants g circle f, so g circle f of x means g on the left, f on the right, so g of f of x. Same order over here. G, f, okay? All right, so that's g of f of x, so replace the f of x by the square root of x minus 1. And that works out really nicely because now we're plugging in x minus 1 in the g, right? So what happens there? You got x squared, so we replace x by square root of x minus 1. So that's what we square, and then minus the 4. That works out nicely. What happens? Square root and the square cancel out. So that's just x minus 1 and then minus 4. So you just wind up with x minus 5. Yes? Is that okay? Good with that? All right. Now, turns out we can do this. What would we do here? Yeah, G circle G. Now you don't have to have, for composition, and I guess for addition and subtraction, all the other, but they will ask us on this, the composition wants to do this. What does that mean? We're composing G with itself, and so make a point about that. So it'd be G of x. So we're using G in both cases there, is what that amounts to. Let's see what we do with that. So first of all, do the parentheses first. So G of x, so replace G of x by x squared minus 4. And then, now we do G of x squared minus 4, and so what does that mean? That's our input value, so we replace the x by x squared minus 4 here in the g function. So go to g both times. So that would be x squared minus 4 squared minus 4. What do you think we should do to that next? Well, it will simplify a little bit if we square that out. So again, we hadn't done it in a while, but we've done it twice now. So yeah, if you got a binomial squared and you're simplifying, go ahead and square that out. Write it out twice, full it. X squared times x squared is x to the 4th. 4 times minus x squared times minus 4 is minus 4x squared. You have another minus 4x squared, and then you got minus 4 times minus 4, 16. 2 in the middle, so we got x to the 4th minus 8x squared plus 16, and then don't forget the minus 4 there. So it does simplify down to x to the 4th minus 8x squared plus 12. That's what I'm getting. Anybody believe that?
Yes.
Thank you. Any questions there? Let me show you one more thing on composition here. And that is this. Kind of go the other way. Find f and g. This isn't number 3 on this. This is a totally different problem. All right. Find f and g such that f circle g of x equals h of x, which here's h of x. So h of x is x minus 5 cubed. I want to find f circle, I want to find f and g such as that I want to find f of x and g of x that would make this composition be x minus 5 cubed. That's basically what I want. I want the composition of these two to be that. Well, what that gets you to think about is, yeah, so there's two things going on there, isn't it? And that's kind of what composition is about. It, you know, you're kind of pointing out that, you know, sometimes you've got multiple things going on within one function. So in this function, what two things are going on? Well, I'm subtracting the 5 and then I'm cubing. And so if you just look at it like that, that's what f and g need to do. One of them needs to subtract the 5 and the other needs to cube. So, and in this case, which one's first? The minus 5 is first, and in the composition, which comes first? F circle g. It's the g, right? G is first in that deal. So what should f and g be? Well, the first thing we do to this is subtract 5, so that's what g needs to do. Subtract 5. And then the other thing is happening there is you're cubing, and so that's what f needs to do. See that? So then if you do the composition, you can check it. You'll get the right thing. All right, so let's do number 2 there. So what if h of x is the square root of 5x plus 1? And you can also kind of look at it as a parentheses thing. Because here, this would be, you know, 5x plus, I don't know if this helps or not, but, you know, the first thing I want to do is the inside, the square roots, inside the square root there. So that's the first thing I do. G is going to be the 5x plus 1, the inside the parentheses there. And then the outside is the square root, so that's what F is. So, yeah. Hopefully that helps on those, helps you out there. Any questions about that?